Welcome back to Chemistry Fundamentals. Today we are diving into something truly fundamental, matter itself. Right now, as you sit in your chair, breathe the air around you, and hold your pen, you are interacting with matter in three different states. But what exactly is matter? And how does it behave differently in these various forms? Let's explore the building blocks of everything around us. Let's start with the basics. Matter is anything that has mass and occupies space, or has volume. This might sound simple, but it is a powerful definition that helps us categorize our world. Now, here is something important to remember. Mass and weight are not the same thing. Your mass, the actual amount of matter in your body, stays the same whether you are here on Earth or on the moon. But your weight would be only 1/6 on the moon because weight is the force of gravity acting on your mass. So, what qualifies as matter? Solids, like the desk you are sitting at, liquids, like the water in your bottle, and gases, like the air you are breathing. But light, heat, sound, and even your thoughts and emotions are not matter. They are forms of energy or abstract concepts with no mass. Think of matter as a dance of particles, and the type of dance determines the state. In solids, particles are like dancers in a tight formation. They are packed closely together in an ordered pattern, vibrating in place but maintaining their positions. This gives solids both definite shape and volume. In liquid, our particle dancers loosen up a bit. They are still close together, but now they can slide past each other, like people moving through a crowded room. This is why liquids have definite volume but take the shape of their container. Gases are where the party really gets wild. The particles are far apart, moving rapidly and randomly in all directions. They fill whatever container they are in completely. No definite shape or volume. There are also a fourth state, plasma, which occurs at extremely high temperature. Think of the sun, lightning, or the gas inside fluorescent lights. Here, electrons are stripped away from atoms, creating an electrically conductive soup of particles. Now, how do we get from one state to another? It's all about energy and breaking or forming the forces between particles. When ice melts at 0 degrees Celsius, we are adding energy to break the tight bonds holding the water molecules in place. Interestingly, the temperature stays constant during this melting process. All that energy goes into breaking bonds, not heating up the water. The same thing happens when water boils at 100 degrees Celsius. We need that heat of vaporization to break the liquid bonds and create steam. Some substances can skip the liquid phase entirely through sublimation. Think of dry ice turning directly into carbon dioxide gas, or how freeze drying works with food. Every substance has two types of properties. Physical properties like color, density, and boiling point can be observed without changing what the substance actually is. And chemical properties describe how a substance reacts with others, like flammability or how it responds to acids. When we combine different substances, we get mixtures. Homogeneous mixtures like salt water look uniform throughout, while heterogeneous mixtures like oil and water have distinct separate phases. The beauty of chemistry is that we can separate these mixtures using different techniques. Filtration separates by size, like brewing coffee. Distillation uses different boiling point. That's how we purify water or make alcohol. Chromatography separates substance based on how fast they move through a medium, crucial for drug analysis and forensics. So remember, matter is all around us, constantly changing states and interacting. Understanding these fundamental properties help us make sense of everything from cooking into your kitchen to industrial processes. See you in the next lecture.